Okay, thank you very much. It's no problem. I know it's not easy to pronounce Innovatiesteunpunt, but it's good that you tried. Thank you very much. So I hope you can see my presentation and hear me all well. Welcome all from my side too. I'm happy to see all those interested people here. I will give you an overview of the potential applications and markets. First, I will tell you a little bit about Innovatiesteunpunt. The Innovation Support Center, if we translate it to English, is a group of about 20 employees that is a part of Boerenbond, a farmers union in Flanders with 15,000 members. We also recently launched our Wallonian sister, Innovatiesteunpunt. We connect researchers to farmers and farmers to researchers. This to stimulate demand-driven research and inform and inspire farmers about new challenges and opportunities. You see it as a one-stop shop. We coach farmers with the development of early innovation projects and their grassroots ideas. We also provide answers to individual questions about various topics, from crops to business ideas and also environmental topics. We support farmers with the implementation of partnerships and organize study events and training sessions like this webinar. On this slide you see our website, so keep track of our website and also the website of our Wallonian sister Agri-Innovation. We do this support to the farmers by our participation in European, national and regional projects. Within our Interact project ID, we want to help starting up the algae value chain by informing farmers about the opportunities of algae farming and helping them to find solutions for the challenges they face with setting up an algae farm. We want to achieve an economical and ecological sustainable algae farm. So where do we see ourselves? We don't do any pure research, but we also don't develop and market products. So actually we are in between. We call it the Valley of Death. So why do we call it like that? Because often a lot of research is done, but it never reaches the companies who need it. So it ends up in the Valley of Death. By our work, we try to avoid that good ideas are getting lost. The first use of algae by humans dates back 2,000 years to the Chinese, who used nostoc to survive during famine. They used edible blue-green algae like nostoc and spirulina that were consumed for thousands of years. In the early 50s, the increase in the world's population and prediction of an insufficient protein supply led to a search for new alternative for protein resources. So algae biomass popped up as a good candidate. Since then, the interest in algae biomass has only grown, and the search for biologically active substances, particularly antibiotics, began. So nowadays there are numerous commercial applications of microalgae. For example, they can be used to enhance the nutritional value of food and animal feed thanks to their chemical composition. The algae can be used as a source of highly valuable molecules, for example, polyunsaturated fatty acid oils that can be added to infant formulas and nutritional supplements. They play also a crucial role in aquaculture for feeding shrimps and fish, for example. We will come back in a presentation of LS Aqua to that. They can be used in cosmetics. Also, the pigments can be used for dyes in food and other applications. They can be used for water treatment to recover nutrients. As fertilizer, they can be used. There's also been, and still going on, research to use it as biofuel and so on. So microalgae have been used by humans for thousands of years, but the really commercial large-scale production of the chlorella genus only started in the 60s in Japan. Although there are many thousands of species of microalgae, there are only a few edible and used for human consumption. That's because there's not done research for all those species, because they're just too much, and some algae are even toxic. In Europe, the number of species that are allowed to be used for human food is even further limited. So if you want to bring new species or even new compounds of species on the market, you need to have an approval for novel food. So that's something you really have to check out. Very common species for human food are chlorella, spirulina, and dunaliella. Sorry, those are the most common to find in and produced in industrial scale, and they are mainly marketed as human nutrition, as tablets or powders in the healthy food market. We also see more and more products, I will come back later to that, where the algae are processed into the human food applications. They are very rich of proteins, vitamins, essential amino acids, and they have potential effects include anti-cancer, antioxidant, antiviral, antibacterial, as well as positive effects against malnutrition, obesity, diabetes, heavy metal and chemical induced toxicity. They also contain lots of minerals, the pigments, like I already mentioned, like chlorophyll A, beta-carotene, also enzymes like lipase. And the possibilities of human nutrition with microalgae are numerous. The microalgae for human nutrition can be incorporated in, for example, candies, beverages, snacks, pastas, juices, and so on. In fact, you cannot think one application for human food where it can be used, I think. The average lipid content of algal cells varies between 1 and 70%, but can even reach 90% of dry weight under certain conditions. So algal lipids are composed of glycerol, sugars, or bases esterified to saturated or unsaturated fatty acids. Among all the fatty acids in microalgae, some fatty acids of the omega-3 and omega-6 families are specifically very interesting. Now it is mostly comes from fish oil, which has its specific taste and odor, and often has to be eliminated. The total amount and relative proportion of fatty acids can be affected by nutritional and environmental factors like nitrogen limitation. So you can steer it a little bit, or it can be counterproductive if you're not able to challenge certain conditions. Microalgae also represent a valuable source of nearly all essential vitamins. And the vitamins improve the nutritional value of algae cells, but their quantity also can fluctuate with environmental factors, harvesting treatment, and even the method of drying the algae. So also be aware of that when you process your algae. So now you have seen all those possible applications of food, you may ask yourself if you have already eaten algae. I think there's a good chance you did. At the left side of the left picture, we see cookies with cranberries and spirulina. That's more or less a special product. In the middle is spirulina tablets. So if you take it, you are aware that you are eating spirulina. But at the right, you see candy frogs colored with colorants based on spirulina. Most people I think have already eaten that without knowing that it contains spirulina, or often contains spirulina. There are a lot of candies colored with spirulina, and so I would challenge you, next time you're at the supermarket, grab a bag of candies and read the ingredients. You'll be surprised how often there are things like spirulina in it. Another application I found is an ice cream. It is called Green Smoothie Gourmet. So it is also based on algae. You can see it by the color. The algae factory also has a chocolate bar with spirulina on the market. They have it with dark chocolate and chocolate with 40% chocolate in it. I even found a recipe of a vegan chocolate chip cookies with matcha and chlorella. So you can make it at your own home when you are interested in it. In Holland, I've been eating a Dutch wheat burger. Maybe you're thinking about other wheats, but this burger is based on 10% seaweed. And the bun is made with chlorella. The bun has the typical green color of the algae. I found products like products from Bertolini farm. It is an Italian farmer that started growing algae on his farm to use it in his own products. They sell it as pure algae in the form of flakes and powders. And they also sell products with algae added to it, like noodles, an energy bar, pasta, and rice crackers. Chlorella is also one of the most frequently used microorganisms in animal nutrition for direct consumption by larvae. During brief periods, mollusks, oysters, shrimps, or indirectly fed live prey fed to small fish. Feeding microalgae has also other benefits. When you feed it to larger fishes, it also avoids that small fish have to be grown to be eaten by bigger fishes to ensure omega-3 uptake. Specific microalgae can be also used as an animal feed supplement, for instance, Chlorella, Synedesmus, and Spirulina. And they have, for example, enhanced the immune system response, improved fertility, and given better weight control. In our IDEA project, we are also doing research for the immune response of animals on the intake of microalgae. One of the most interesting approaches, like Lynn also mentioned, is the approach of the application of cosmetic formulations. Components of microalgae, typically, again, Chlorella vulgaris, are often used in cosmetics. Microalgae have the sun protection skills thanks to the presence of chlorophyll A. And Chlorella extract is also used by the skincare industry, since some compounds have anti-aging, refreshing, regenerant, emollient, and anti-irritant properties. Microalgae of Chlorella genus can produce metabolites, so they can protect themselves from ultraviolet radiation. So also there are some applications possible. There are already some microalgae-based cosmetics commercially available for skin hydration and also for skin cell renewal. Another example I found is a product that is produced from Chlorella vulgaris extract, which shows, for example, firming and restructuring and eye contour effects. Besides, it stimulates the synthesis of collagen. In addition, it decreases the morphology of stretch marks and reduces vascular imperfections. Algae can also be used for wastewater treatment. In wastewater treatment, there are generally two subsequent treatments. The first step is the sedimentation of materials, and second step is the oxidation of the organic materials. This results in a apparently clean effluent that is disposed into the aquatic environment. This effluent is, however, loaded with inorganic nitrogen and phosphorus and causes eutrophication and problems because of refractory organics and heavy metals that are discharged. Microalgae culture can provide a third treatment due to the ability of microalgae to use inorganic nitrogen and phosphorus for their growth. At the same time, biomass is produced, so it can be used for several purposes. Microalgae are also capable to remove heavy metals, as well as some toxic organic compounds. This means that microalgae for food and feed have to be checked for heavy metals and toxic compounds. As we have in Europe a strong legislation, it is always interesting to check for this check for contamination could be a reason for more local sourcing of microalgae instead of, for example, sourcing algae from China, where might be another legislation concerning the heavy metals and toxic compounds. Chlorella has the abilities to fix carbon dioxide efficiently and to remove nutrients like nitrogen and phosphorus. So Chlorella has been tested to remediate aquaculture wastewater from a fish farm. And there's also an interesting Interreg Northwest Europe funded project called ALGAT, which is developing new technology to take excess waste nutrients produced from anaerobic digestion of food and farm waste to cultivate algal biomass for animal feed and other products of value. You certainly heard of the possible application of biodiesel. Biodiesel is a clean alternative fuel source that could replace fossil fuels. Usually, biodiesel is produced from crops like soybean and sunflower, which leads to issues in terms of deforestation, world hunger, and land pollution. Regarding microalgae-based biofuels, mainly biodiesel and biogas have been investigated. The lipids from microalgae up to 75 weight% can be extracted and used to produce biodiesel. Producing biodiesel with biogas with microalgae is also possible. In this sense, microalgae lipids are one of the most promising feedstock to produce biodiesel, since they do not compete with food crops and have a high content of lipids. However, the current high cost of biodiesel from microalgae makes its production for the moment industrial scale infeasible. Maybe the use of microalgae lipids to produce biodiesel using the mixotrophic metabolism of algae growing on agro-industrial waste will be feasible in the future. The biogas is another possibility, and this can be produced from microalgae by the anaerobic digestion of microalgae by anaerobic bacteria. The biogas yield is also here highly affected by the species of the microalgae, the type of pretreatment, organic loading, retention time, temperature, pH, etc. So also there, like Leen mentioned, you have to know what you want to achieve to get the product you want at the end. So maybe now you're triggered to start with algae growth, but now the question pops up, where do I have to start? First question, also mentioned by Leen, is why do you want to grow the algae? Maybe you want to recover nutrients from your feeding water in your greenhouse, or maybe manure. The second question that you have to ask yourself, do you have a client in mind who is interested in your algae? And the third question is quite a large question. The destination of your algae determines more or less everything you have to decide. So what algae to grow, the cultivation system, nutrients, salinity, pH, temperature, even the harvesting method, because that can cause stress, and the moisture content of your end product. So how much moisture do you have to remove from your algae to get it to your client? Once the algae are grown, you have to valorize them. You can process them in your own products, like feed for your animals, which tends to be quite expensive. Use for your own aquaculture if you have it. You could use it in ice cream like we have seen, cookies, smoothies. You could sell it as a whole dried algae in the form of powder, flakes or tablets. But always be aware of the novel food legislation. Another possibility, if you don't want to process your own algae, you could sell it to a processor who can do it for you and maybe deliver you the dry product, or sell the dry product to another processor who processes it in, for example, food. The challenges for algae farm are that you have to find an application you want to grow for, the energy source that you want to use for the algae, as some algae can be grown onto autotrophic or heterotrophic. Ideally, it would be a source that is excessively present on the farm, like CO2 from a biodigester or digestate. You have to choose your growth system, so there are lots of possibilities. Some vary a little bit, other are complete other systems. You have to choose the growth conditions for the aimed application. Like we have seen, it can change the composition of the algae, and the further processing steps like harvesting, conservation, transport and drying. So there's quite some things to think about, and it's quite some work to sort things out. So starting the whole value chain of production, transport and sales is on your own is a very difficult and risky business. So that's why I would like to end with the advice to work together with within a federation or cooperative, so you can tackle challenges together. Thanks.